The scientific revolutions. The period between 1300 and 1600 was a time of great change in Europe. The Renaissance inspired a spirit of curiosity in many fields. Scholars began to question ideas that had been accepted for hundreds of years. While the Reformation was taking place, another revolution in European thought had begun, one that would permanently change how people viewed the physical world.
The roots of modern science. Before 1500, scholars generally decided what was true or false by referring to an ancient Greek or Roman author or even the Bible. Here we have two important aspects at that time. The medieval view. Most scholars believed that the earth was a mobile object located at the center of the universe. After all, the sun appeared to be moving around the earth as it rose in the morning and set in the evening. This earth-centered view of the universe was called the geocentric theory. The Greek astronomer Ptolemy expanded the theory in the 2nd century AD. The second important aspect is a new way of thinking. As scholars replace old assumptions with new theory, they launched a change in European thought that historians call the scientific revolution. The scientific revolution was a new way of thinking about the natural world. During the Renaissance, European explorers traveled to Africa, Asia, and the Americas. The age of European exploration also fueled a great deal of scientific research, especially in astronomy and mathematics. They found they had researched the limit of the classical world's knowledge.
A revolutionary model of the universe. An early change to accepted scientific thinking came in the field of astronomy. It started when a small group of scholars began to question the geocentric theory. The geocentric theory did not accurately explain the movement of the sun, moon, and planets. This problem troubled a Polish cleric and astronomer named Nicholas Copernicus, who became interested in an old Greek idea that the sun stood at the center of the universe. After studying planetary movement for more than 25 years, Copernicus rethought that indeed the star, the Earth, and the other planets revolved around the sun. Copernicus' heliocentric or sun-centered theory still did not completely explain why the planets orbited the way they did. He also knew that most scholars and clerics would reject his theory because it contradicted their religious view. Copernicus did not publish his findings until 1543, the last year of his life. He received a copy of his book, On the Revolution of the Heavenly Body, on his deathbed. Copernicus' book caused a little stir at first. Over the next century and a half, other scientists built on the foundation he had laid. A Danish astronomer, Tycho Brahe, carefully recorded the movement of the planets for many years. However, it was left to his followers to take mathematical sense of them. After Brahe's death in 1601, his assistant, a brilliant mathematician named Johannes Kepler, continued his work. Kepler concluded that certain mathematical laws govern planetary motions. One of these laws showed that the planets revolve around the sun in elliptical orbit instead of a circle, as was previously thought. Kepler's law showed that Copernicus' basic ideas were true. They demonstrated mathematically that the planets revolve around the sun. An Italian scientist named Galileo Galilei built on the new theory about astronomy. As a young man learned that a Dutch lens maker had built an instrument that could enlarge far-off objects and built his own telescope to use it to study the heavens in 1609. Then, in 1610, he published a small book called Starry Messenger, which described his astonishing observations. Galileo announced that Jupiter had four moons and that the Sun had dark spots. He also noted that the Earth's moon had a round, uneven surface that shattered Aristotle's theory that the moon and star were made of a pure, perfect substance. Galileo's observation as well as his law of motion also clearly supported the theory of Copernicus. Galileo's finding frightened both Catholic and Protestant leaders because they went against church teaching and authority. In 1616, the Catholic Church warned Galileo not to defend the ideas of Copernicus. Galileo remained publicly silent and he continued his study. Then, in 1632, he published Dialogue concerning the two chief world systems. This book presented the ideas of both Copernicus and Ptolemy, but it clearly showed that Galileo supported the Copernican theory. The Pope summoned Galileo to Rome to stand trial before the Inquisitions. Galileo stood before the court in 1633. Under the threat of torture, he knelt before the cardinals and read aloud a signed confessions. In it, he agreed that the ideas of Copernicus were false. Galileo was never again a free man. He lived under house arrest and died in 1642 at his villa near Florence. However, his books and ideas still spread all over Europe, and finally, in 1992, the Catholic Church officially acknowledged that Galileo had been right.
The scientific method is a logical procedure for gathering and testing ideas. It begins with a problem or question arising from an observation. Scientists next form a hypothesis. The hypothesis is then tested in an experiment or in the basis of data. In the final step, scientists analyze and interpret their data to reach a new conclusion. That conclusion either confirms or disapproves the hypothesis. Bacon and Descartes believed that scientists needed to reject all assumptions and teaching. Descartes relied on mathematics and logic. He believed that everything should be doubted until proved by reason. The only thing he knew for certain was that he existed, because, as he wrote, I think, therefore I am. From this starting point, he followed a train of strict reasoning to arrive at other basic truths.
Newton explains the law of gravity. By the mid 1600s, the accomplishments of Copernicus, Kepler, and Galileo had shattered the old views of astronomy and physics. Later, the great English scientist Isaac Newton helped to bring together their breakthroughs under a single theory of motion. Here shows the changing idea of scientific method. In all science, scholars generally relied on ancient authorities, church teachings, common sense, and reasoning to explain the physical world. In new science, in time, scholars began to use observation, experimentation, and scientific reasoning to gather knowledge and draw conclusions about the physical world. In 1628, Harvey reveals how human heart functions. In 1628, Harvey reveals how human heart functions. In 1633, Galileo faces inquisition for support of Copernicus' theory. In 1637, Descartes' book Discourse on Method sets for his scientific method of reasoning from the basis of doubt. In 1643, Torricelli invents barometer. In 1660, England establishes Royal Society to support scientific studies. In 1662, Boyle discovers mathematical relationship between the pressure and volume of gases, known as Boyle's law. In 1674, Leeuwenhoek observes bacteria through microscope. In 1687, Newton publishes Law of Gravity. And in 1714, Fahrenheit invents mercury thermometer. Isaac Newton's law of gravity explained how the same physical laws governed motion both on Earth and in the heavens. Newton studied mathematics and physics at Cambridge University. By the time he was 26, Newton was certain that all physical objects were affected equally by the same forces. Newton's great discovery was that the same force ruled motion of the planets and all matter on Earth and in space. The key idea that linked motion in the heavens with motion on the Earth was the law of universal gravitation. According to this law, every object in the universe attracts every other object. The degree of attraction depends on the mass of the objects and the distance between them. In 1680, Newton published his ideas in a work called The Mathematical Principles of Natural Philosophy. It was one of the most important scientific books ever written. The universe he described was like a giant clock. Its parts all worked together perfectly in a way that could be expressed mathematically. Newton believed that God was the creator of this orderly universe, the clockmaker who had set everything in motion.
The scientific revolution spread. As astronomers explored the secret of the universe, other scientists began to study the secret of nature on Earth. Here we have three important aspects. The first one is the scientific instrument. In 1643, one of Galileo's students, Evangelist Torricelli, developed the first mercury barometer, a tool for measuring atmospheric pressure and predicting weather. In 1714, the German physicist Gabriel Fahrenheit made the first thermometer to use mercury in glass. Fahrenheit thermometer shows the water freezing at 32 degrees. In 1742, a Swedish astronomer Andrew Celsius created another scale for the mercury thermometer. The second aspect is medicine and the human body. During the Middle Ages, European doctors had accepted as fact the writing of an ancient Greek physician named Galen. However, Galen had never dissected the body of human being. Galen assumed that human anatomy was much the same. A Flemish physician named Andreas Vesalius proved Galen's assumption wrong. Vesalius dissected human corpses and published his observations. His book on the structure of the human body was filled with detailed drawing of human organs, bones, and muscles. And the last important aspect is discoveries in chemistry. Robert Boyle, pioneer in use of the scientific method of chemistry, he proposed that matter was made up of smaller primary particles that joined together in different ways. Boyle's most famous contribution to chemistry is the Boyle's law. The notion of reason and order, which spurred so many breakthroughs in science, soon moved into another field of life. Philosophers and scholars across Europe began to rethink long-held beliefs about the human conditions, most notably the right and liberty of ordinary citizens.